GPU. A video display adapter, otherwise known as a GPU or a graphics processing unit, provides the connection between your computer and your monitor and transmits the signals that appear as images on the display. For the image shown, you will see a graphics card's PCB or printed circuit board. Technological specs that are inside of a GPU. CUDA cores. A CUDA core is NVIDIA's equivalent to AMD's Stream processors. NVIDIA's proprietary parallel computing programming model, CUDA, is a specialized programming language that can leverage the GPU in specific ways to perform tasks with greater performance. Each NVIDIA GPU can contain hundreds to thousands of CUDA cores. CUDA cores are parallel processors. NVIDIA GPUs host several hundred or thousand cores. The cores are responsible for processing all the data that is fed into and out of the GPU, performing game graphics calculations that are resolved visually to the end user. An example of something a CUDA core might do would include rendering scenery in-game, drawing character models, or resolving complex lighting and shading within an environment. Stream processors. Like NVIDIA's CUDA cores, AMD's Stream processors are a more central component of the GPU. Stream processors and CUDA cores are not linearly comparable due to vast architectural differences, but can be thought of as similar when it comes to the primary function of each component. Stream processing is focused intensely on parallelism of datasets to ensure efficient processing when performing tasks that are better suited for parallel processing. RTX ops. The ray tracing performed by the RT cores can be used to produce reflections, refractions, and shadows, replacing traditional raster techniques such as cube maps and depth maps. Gigarays per second. The term gigarays per second suggests how many rays can be traced in a scene per second. The more rays that can be traced, the more immersive a scene will look and feel in terms of the ray tracing effect on lighting and shadows. GPU base clock. This is the operating frequency of the graphics processing chip found on the video card. GPU boost clock. This is the graphics processor unit's boost GPU speed measured in megahertz or gigahertz. Memory speed. The memory speed is the speed that the memory operates at, measured in gigabits per second. Standard memory configuration. Otherwise known as the VRAM or Video Random Access Memory, it is the amount of memory the GPU has, and it is used for storing graphical textures and 3D models temporarily. This is measured in gigabytes. Memory interface. This is the physical bit width of the memory bus. Every clock cycle, data is transferred along a memory bus to and from the on-card memory. The width of this interface is the physical count of bits that can fit down the bus per clock cycle. For example, a device with a 384-bit memory interface would be able to transfer 384 bits of data per clock cycle. The memory interface is also a critical component of the memory bandwidth calculation in determining maximum memory throughput on a GPU. Memory bandwidth. Memory bandwidth is one of the most frequently showcased stats for any new GPU, often rating in hundreds of gigabytes per second of throughput potential. Memory bandwidth is the theoretical maximum amount of data that the bus can handle at any given time, playing a determining role in how quickly a GPU can access and utilize its VRAM. Pixel fill rate. This refers to the number of pixels a video card can render to a screen and write to video memory in a second, or in case of texture fill rate, the number of texture map elements a GPU can map to pixels in a second. They are given in gigapixels per second. Texture fill rate. The texture fill rate of the GPU is representative of how many pixels the GPU can render per second. This value is always represented as a measurement over time. This is measured in gigatransfers per second. ROPS. Render output units, also known as raster operations pipeline, which is more useful in determining the application of a ROP. A render output unit is a specific component on a GPU that is responsible for the processing of final pixel values prior to drawing them onto the screen. ROPs perform pixel read-write tasks that include processing pixel and texel data. Render output units interpret the final depth of pixels before rendering them onto the screen. Texture unit. This is a low-level GPU component that operates with some independence, entirely dedicated to manipulating bitmaps and texture filtration. Texture map units modify bitmaps for placement onto objects and filter textures. In video games, this would be represented as placing a texture onto an object. Compute unit. This is a stream multiprocessor in an AMD GPU. Reference card versus non-reference card. Reference card. Blower type cooler uses an impeller to suck air in at one end, force it through the length of the card that has heat sinks in strategic locales, then exhaust out the back of the card. Non-reference card. Printed circuit board elements can be moved and/or altered. One common tactic is to use higher quality components such that you have a better, more robust power delivery subsystem to help with overclocking. There is also a custom cooler that contains large heat sinks, large fans, and heat pipes. Reference cards are comparatively cheap and fast to crank out. The trade-off is that a blower type cooler runs loud and is not the best at cooling. Non-reference cards have the cost and engineering delay of a custom PCB or printed circuit board and custom coolers. The trade-off is you get better performance and quieter operation.